Hi, this is Jeff Minter with Automotive Research and Design. I'm here today with a hybrid vehicle tech tip from P10. Today's tech tip topic will be covering electric machines. We'll talk about what they are and what purpose they serve in a hybrid electric vehicle. So what is an electric machine? Well, an electric machine is simply an electromechanical device and can be used either as a motor or a generator depending on the current needs of the vehicle. As you can see in this picture, there are different configurations that can be used to create an electric machine to be used in a hybrid or electric vehicle. All electric machines have two common parts. It's going to be the rotor as well as the stator. We'll look at a couple of different designs of both today as we go over the different configurations of these hybrid electric machines. Currently, there are two main different types of rotors being used in the hybrid electric machines. Now, both of these can come in different configurations, but there are two basic types. The first is called a permanent magnet brushless DC motor. In this motor, the rotor assembly contains rare earth magnets that are relatively expensive and are becoming a little bit more difficult to get. The other type of machine is called an AC induction machine. The AC induction rotor does not have any magnets in it. Instead, it has conductive paths that are cast into it using generally aluminum or copper that provide a current path, and through a mutual induction process will actually create electromagnets within the rotor assembly. Now, don't confuse either of these with a brushed electric machine. Neither one of these use brushes. It's just simply that one has permanent magnets in it and the other one does not. We just looked at a few differences in the rotor design types, but there are also a few differences available in the stator design types. And you'll see different ones used in different applications because they both have different operating characteristics. The first one that we'll look at is called a concentrated wound. As you notice at the top there, each one of these stator poles are wrapped around its own individual core, so they have a very concentrated field in that one area. The other type is called a distributed wound. The distributed wound, as you may be able to see in the screenshots there, contain windings that overlap each other. So the phases, rather than being totally isolated from one another, actually overlap each other significantly throughout the field, which is why they call it a distributed, because the magnetic field is distributed over a larger area within that stator assembly. Regardless of the motor design, whether it's a permanent magnet brushless DC motor or an AC induction motor, or for that matter whether it's concentrated wound or distributed wound stators, they're all currently using three-phase AC current in these electric machines, whether it's in a full electric or it's in a hybrid electric vehicle. This three-phase AC current is going to be generated from a DC source. So the DC source will obviously be the high voltage battery as well as any output from a motor that's currently serving as a generator. In other words, that generation power would have to be put into a DC format, put onto a DC bus, and then be utilized to create that three-phase AC current. The AC current is going to be supplied to the electric drive motor by the inverter assembly. The inverter assembly is going to control two different things in order to control the operation of this machine. It's going to control the frequency, which will dictate the speed of the machine, and it's going to control the amplitude of that current, which will dictate the amount of torque that the motor is currently producing, along with some other things that we don't have time to get into in this segment, called lead and lag, or the degree of slip. This was obviously just a very brief overview of the hybrid electric machines as a whole. We are going to have more information coming up in a segment on diagnostics related to these electric machine failures, and there's also a lot more information available on our website if you're interested in learning more about hybrid electric machines. Thank you for joining us for this hybrid vehicle tech tip brought to you by P10. Hopefully you'll join us for a future segment where we'll go more in depth into the diagnosis of these hybrid electric machines.